The universe should be screaming with voices.
It is not.
Every calculation says intelligent life should be common, widespread, and detectable. The numbers are not subtle. Hundreds of billions of stars in our galaxy alone. Tens of billions of years for life to emerge. Planets orbiting those stars in numbers we could not have imagined 50 years ago. And yet we have been listening for 65 years across every wavelength we can reach. And the answer is silence. Complete, unwavering, absolute silence. The silence is not a question. It is an answer. We have been afraid to read it. Prepare yourselves. We begin. It was a summer afternoon in 1950, and four of the most dangerous minds of the 20th century were sitting down to lunch in the cafeteria at Los Alamos National Laboratory in New Mexico. Enrico Fermi, the man who had built the world's first nuclear reactor, Edward Teller, who would later design the hydrogen bomb, Emil Konopinski, a physicist who had worked on the Manhattan Project, Herbert York, a young scientist who would go on to lead the Lawrence Livermore National Laboratory. They were talking about flying saucers. A cartoon in The New Yorker had shown little green men stealing New York City's trash cans. The joke was harmless, the conversation light. Then Fermi went quiet. He did the math in his head the way he always did, the way that had made him one of the most feared intellects of his generation. The galaxy is 13 billion years old. It contains hundreds of billions of stars. Even at a fraction of light speed, a single civilization could colonize the entire Milky Way in a few million years. That is 0.1% of the galaxy's age. The silence should be impossible. He looked up from his tray and asked four words that have haunted science for 75 years. Where is everybody? The question sounds simple. It is not. Most people hear it as a question about distance. The galaxy is huge. The stars are far apart. Maybe the aliens are out there, but they are too far to reach. That answer feels reasonable. It also misses the point entirely. Fermi was not asking about space. He was asking about time. A galaxy that old with that many chances should have produced civilizations that rose, peaked, and spread across the stars long before Earth had oceans. The fact that we see nothing, hear nothing, find nothing means something is wrong. The question was never about where they are, it was about when. And the when is the part that most people never sit with long enough to feel. Fermi died in 1954, 4 years after that lunch. He never got to see his question grow teeth. But the teeth were always there, hidden in the math he ran in his head, while his colleagues laughed about flying saucers. The question outlived him by generations, and it has only grown heavier. Every year we add to the count of years we have been listening, and every year the sky gives us back the same answer.
Nothing.
The silence is not a gap in our search. It is a wall, and we have been walking into it for 75 years without admitting what it means. 11 years after Fermi's question, a young radio astronomer at Cornell University named Frank Drake sat down in front of a chalkboard at the Green Bank Observatory in West Virginia. He was preparing for the first serious scientific meeting ever devoted to the search for extraterrestrial intelligence. He needed an agenda, something to organize the discussion, a way to make the problem feel solvable. What he wrote instead became one of the most famous formulas in all of science. The Drake equation multiplies 7 factors together, the rate at which new stars form in the Milky Way each year, the fraction of those stars that have planets, the number of potentially habitable planets per star system, the fraction of those planets where life actually emerges, the fraction of life-bearing planets where intelligence develops, the fraction of intelligent species that build detectable communications technology, and finally, the average lifespan of a communicating civilization in years. Multiply them all together, and you get an estimate of how many civilizations are broadcasting right now. Drake never intended it as rigorous science. He would say so himself for the rest of his life. But the equation did something powerful. It turned a vague philosophical mystery into something that looked like a math problem. At the Green Bank meeting, Drake plugged in his best guesses and got an answer of roughly 10 civilizations in the Milky Way transmitting at that moment. Carl Sagan thought the number might be in the millions. The room debated eagerly. The equation had done its job. But hiding inside that math problem was something quietly devastating. 3 of the 7 factors are knowable, at least approximately. We have good numbers for star formation rates, planetary frequencies, and habitable zone statistics. Those numbers are encouraging. Almost every star has planets. Roughly 1 in 5 Sun-like stars hosts a rocky world in the habitable zone. The remaining 4 factors are something else entirely. The probability of life emerging, the probability of intelligence, the probability of technology, and the lifespan of a civilization. We have exactly one data point for all 4 of them combined. That data point is us. The last factor is the trap, the lifespan of a communicating civilization. It is the one we can never know, and it is the one that determines everything. Plug in optimistic numbers, and the equation gives you hope. Civilizations last for millions of years. The galaxy is teeming with voices. Plug in realism, and the equation collapses. Civilizations last for centuries. The galaxy is silent. The equation is not wrong. It is incomplete. It leaves out the one thing that changes everything. And that missing factor is not about space at all. The Drake equation calculates how many civilizations exist right now. That is the question it was designed to answer. How many are broadcasting at this very moment, close enough for us to detect, within the narrow window of our listening? But there is a different question the equation does not ask. How many civilizations have ever existed across the entire history of the galaxy? Those two numbers are not the same. They are not even close. A galaxy could have produced 10,000 civilizations across its history and have 0 broadcasting at this moment. The difference between ever existed and existing now is the lifespan of a civilization. That is the hidden variable. The equation treats lifespan as one factor among 7. But lifespan is not just another number. It is the number that determines whether the equation produces hope or silence. Consider the arithmetic. Suppose 1,000 civilizations have arisen across the last 10 billion years of galactic history. That is a conservative estimate, given the number of stars and planets. Now, suppose each of those civilizations broadcasts for an average of 500 years before going silent, either because they collapsed, evolved past radio, or simply stopped transmitting. The expected number broadcasting at any single moment becomes the total number of civilizations multiplied by the broadcast lifetime divided by the total time span. 1,000 multiplied by 500 divided by 10 billion. That equals 0, 5, effectively 0. The math is brutal. Even 1,000 civilizations across cosmic history produce a snapshot of silence. You could have 10,000 civilizations and still see nothing at any given moment if their broadcast windows are brief enough. The galaxy could be bursting with life, with intelligence, with technology, and every single observer at every single moment would look up and see an empty sky. Not because the civilizations are not there, because they are not there at the same time. This is what the original Drake equation hides. It calculates a theoretical maximum without accounting for the fact that civilizations are spread across time, not just space. The equation gives us hope by suggesting the math is favorable, but the hidden variable takes that hope and reorganizes it. There may have been many voices. There may yet be many more. We are just listening at the wrong moment, and our own broadcast window is still ticking down. The Milky Way is 13 billion years old. Human civilization, the kind with cities and writing and law, is roughly 6,000 years old. Radio technology, the only thing we have ever used to search for voices beyond our planet, is 130 years old. Stack those numbers next to each other and the picture becomes almost painful. The fraction of Earth's existence during which Earth has been a radio source is so small it barely registers as a rounding error. Compress the entire history of Earth into a single calendar year. The planet forms on January 1st. Single-celled life appears in late February. Multicellular life shows up in mid-November. Dinosaurs walk in late December. Humans evolve about 30 minutes before midnight, on December 31st. The first radio broadcast happens in the last quarter of a second before the year ends. That quarter second is our window of detectability. It is also the only window we have ever used to search. Think about what that means. Every radio telescope ever built, every hour of listening time ever logged, every search program ever funded has been operating inside that quarter second. We are listening for civilizations that might be broadcasting during their own quarter second. and we are assuming those quarter seconds overlap with ours. The galaxy is 100,000 light years across. Our radio bubble, the sphere of signals we have leaked into space since the 189s, has reached about 1% of it. We have been shouting into an ocean and checking only the patch of water directly beneath our feet. The standard reaction to this is to say, we need better equipment, bigger telescopes, more sensitive receivers, more computing power. Those things would help. They would help us hear fainter signals from farther away, but they would not solve the temporal problem. A bigger ear does not help you hear something that stopped broadcasting before you were born. A more sensitive microphone does not pick up a voice that went silent a million years ago. We are searching for a needle in a stack of needles, but we are only looking in the top layer. The rest of the stack is buried in time we cannot reach. Here is the part that most discussions of the Fermi Paradox never quite say out loud. The question is not about aliens. It is about us. Every silence has a cause. The cause tells us something about the universe, yes, but it also tells us something about our own position in it. We are not asking why the sky is empty, the way a tourist asks why a museum is closed on a Tuesday. We are asking what happens to civilizations like ours. The answer could be that we are alone. The conditions required for life are so impossibly precise, so statistically unlikely, that Earth is the only planet in the galaxy where chemistry ever organized itself into something that could look back and wonder. That answer is lonely. It places an enormous weight on every decision we make. If we are alone, there is no backup, no second attempt at consciousness waiting somewhere in the dark. If we fail, the universe returns to the state it has been in for most of its history. Darkness without a witness. The answer could be that they are all dead. Civilizations rise, develop technology, and then something stops them. Something that happens every time, or almost every time. The mechanism might be internal. A technology they built, a choice they made, a fragility they could not engineer around. The mechanism might be external. A force operating in the galaxy that removes civilizations from the record before they can leave a lasting mark. Either way, the silence is the residue of extinction. We are not looking at an empty universe.
We are walking through a graveyard.
The answer could be that they are hiding. They know we are here. They have always known. They choose deliberately and continuously to leave us alone. Earth is a preserve, a nature reserve, a zoo. We are the animals inside it, developing in isolation, entirely unaware that the enclosure is maintained by something we cannot detect. That answer is unsettling for a different reason. It requires that every technological civilization in the galaxy agrees unanimously, and without defection, to leave humanity alone. One exception breaks the arrangement. The fact that it is held suggests either that every civilization independently arrives at the same conclusion, or that something enforces the agreement. Each answer carries a different implication for our own survival. That is what makes the question terrifying. We are not asking why the sky is empty, the way a child asks why a room is dark. We are asking what happens to civilizations that reach our level of development, and the silence we hear is the only data we have. Every proposed solution to the Fermi Paradox, from the loneliest to the most violent, points in the same direction. The universe does not treat the long-term survival of technological civilizations as a default outcome. The galaxy is empty of visible evidence even after 13 billion years. That is the one thing every solution agrees on, and that agreement is the most important sentence in this entire investigation. Picture the galaxy as a theater. The stage has been open for 13 billion years. Civilizations are actors who walk on, perform their brief scene and exit. The lights never dim, the show never stops. But each actor only performs for a few minutes out of a 13 billion year run. Walk into that theater at a random moment. What are the odds you see anyone on stage? Almost zero. You would see an empty platform, dust drifting through the spotlight, and silence. Not because no one ever performed, because almost no one performs at the same time. This is the temporal version of the Fermi Paradox, and it changes everything. When scientists talk about the search for extraterrestrial intelligence, they almost always assume the aliens are out there right now, broadcasting right now, waiting to be heard right now. Every radio telescope pointed at the sky operates on that assumption. The astronomers tuning into distant stars are listening for present tense voices. But the universe does not work in present tense. Light from the nearest star takes over 4 years to reach us. Light from the center of the galaxy takes 26,000 years. Light from the edge of the visible universe takes more than 13 billion years. Every photon you have ever seen is a piece of the past delivered late, sometimes ancient beyond comprehension. So, when we listen to the sky, we are not hearing what is happening. We are hearing what already happened, sometimes recently, sometimes a million years ago, sometimes before life on Earth crawled out of the sea. This means the silence we hear could mean two completely different things. Either no civilization ever existed in the places we are listening, or many civilizations existed, sent their signals, and those signals washed past Earth, long before humans built the first radio receiver. The second option is worse. It means the galaxy is not empty. It is full of echoes. We missed voices that called out into the dark and reached our solar system when there was nothing here but dinosaurs or trilobites or boiling lava. The silence is not proof of absence. It is proof of timing. And once you understand that, the next question becomes unbearable. How late are we? A civilization's detectability window is not its entire existence. It is the brief period when it is loud enough to be heard. This is a distinction that changes everything. A species might inhabit its planet for millions of years, evolve language, build cities, develop art and philosophy and science. None of that matters for detection. What matters is the narrow slice of time when that civilization happens to be broadcasting into space at a power level another civilization could pick up. For Earth, that window opened in the 1890s with the first radio transmitters. It has been open for 130 years. That is the entire span of our detectable existence. Everything before that, every invention, every war, every poem, every moment of human history before the late 19th century is invisible to anyone listening from another star. We existed for 299,870 years as a species before we became detectable, and we have only been detectable for 130 of them. The window is already closing. Radio signals are fading. In the early 20th century, broadcasts were enormous. High-powered transmitters blasted signals in every direction. Anyone listening from another star with the right equipment could have caught the leakage. Old TV broadcasts, radio shows, military radar pulses. They were crude, but they were loud. Today, communications are different. Fiber optics carry signals through cables that leak almost nothing. Cellular networks use tight beams aimed at specific antennas. Satellite communications are focused and encrypted. Digital signals look more like noise than messages. From a distance of a few light years, modern Earth is becoming quieter, not louder. If our window lasts only 200 years before we go silent or evolve past radio, that is the entire span. 2 centuries out of 4, 5 billion years of Earth history. A flash so brief it barely registers. And we are already past the halfway point. The loudest era of human broadcasting was the mid-20th century. The peak has come and gone. We are now in the descending slope. Every year, we leak a little less energy into space. Every year, our window contracts. Now scale that across every civilization in the galaxy. Imagine every intelligent species follows a similar pattern. They develop radio. They broadcast for a few centuries. Then they either collapse or transition to a quieter form of communication. The chance of overlapping windows becomes vanishingly small. 2 civilizations must not only exist at the same time, they must both be in their broadcast phase at the same time, within the same region of space, close enough for signals to cross the distance before the window closes. The math is brutal. It is like trying to have a phone conversation where each person is allowed to speak for 2 seconds randomly sometime in the next century. You would never connect. The terrifying implication is that the silence we hear is not evidence that no one is out there. It is evidence that almost no one is currently within their detectable window pointed our way with us listening at the right moment. The galaxy could be full of civilizations that have already come and gone through their broadcast phase. They were loud. They sent signals. But those signals arrived at Earth when there was nothing here but bacteria or dinosaurs or ice. We missed them. We will always miss them. And the same thing will happen to us. Our signals are already expanding outward, carrying the story of a brief, noisy species into the dark. They will pass star systems that are empty now, but might host listeners in the distant future. By the time those listeners hear us, we will be gone. Our window will have closed. We will be another echo in a galaxy full of echoes, waiting for someone to listen at the right moment. Imagine a field at dusk, in the middle of summer. Fireflies blink across the lawn. Each one lights up for a fraction of a second, then goes dark. Watch for an hour, and you see thousands of flashes scattered across the grass. No two happen in the same spot at the same moment. The field is alive with light, but if you freeze the frame at any single instant, you see nothing but darkness. The fireflies are real. They are everywhere, but the timing of their flashes ensures that no two ever share the same moment in the same place. Now imagine those fireflies are spread across the galaxy. Instead of blinking once a second, they blink once every 100 million years. That is what the search for alien civilizations actually looks like. A civilization is a flash. It begins, it grows, it sends out whatever signature it can, and then it ends, whether by collapse, by self-destruction, by transformation into something we would not recognize, or by simply outliving its own technology. The flash might last a few thousand years. It might last a few million. Either number is brief against the age of the galaxy. Now picture two such flashes. One happens in a star system 50,000 light-years away, 200 million years ago. The other happens in our own solar system right now. Both are real.
Both are technological.
Both broadcast signals into the dark, but they will never see each other. The first signal washed past Earth long before our planet had birds. By the time we built radios, that civilization had been gone for almost as long as the dinosaurs. Their light is still traveling, of course. It has crossed into other parts of the galaxy by now. Maybe it reached some other listener. Maybe it reached no one. Either way, it is not coming back. The window for that conversation closed 200 million years ago. This is the firefly problem in cosmic form. You can have a galaxy absolutely teeming with intelligent life and still have every single civilization feel utterly alone. The math allows for thousands of them to exist over the lifetime of the Milky Way, without any two ever overlapping in time and space close enough to communicate. Astronomers call this the problem of synchronization. For a conversation to happen, two civilizations need to exist at the same moment, within a reachable distance, both with the technology to send and receive, and both willing to broadcast. Miss any of those conditions, and the conversation never starts. The galaxy makes synchronization brutally hard. A civilization broadcasting from one side of the Milky Way needs roughly 100,000 years for its signal to reach the other side. If that civilization only lasts 10,000 years, the signal will outlive its makers by a factor of 10. By the time the message arrives, the senders are dust. This means the sky around us could be full of expired transmissions, letters from the dead, echoes from species that finished their entire history before we invented the wheel. You will not hear them by listening for live conversation. You can only hear them by listening for ghosts. And here is where the firefly metaphor turns dark in a way that matters. Even in a real backyard, if no two fireflies blink in the exact same spot, you still see the field is alive. You see the pattern? You know they are there. In the galactic version, the flashes are so rare and so spread out that you might watch for 1,000 human lifetimes and never see a single one. The field would look dead, not because nothing is there, because you are watching at the wrong second. The galaxy could be bursting with civilizations that have risen and fallen across deep time, and we would never know. We would look up, see silence, and conclude we are alone. The conclusion would be wrong, but we would have no way to prove it. The galaxy is 13 billion years old. The first stars capable of hosting rocky planets appeared roughly 11 billion years ago, when the universe was still young and chaotic. Those early stars forged the heavy elements that make terrestrial worlds possible. They exploded, scattered their material across space, and seeded the next generation of star systems with the raw ingredients for biology. Planets capable of supporting life could have existed as far back as 8 to 10 billion years ago. Earth, by comparison, is only 5 billion. We are not the first opportunity. We are one of the most recent. Consider what that means. The universe has been running the experiment of planetary formation for nearly 3 times longer than Earth has existed. Some of those older planets, by the laws of statistics, must have produced life. Some of that life, by the same laws, must have produced thinkers. Those thinkers had a head start on us, measured not in centuries, but in eons. A civilization that began even 100 million years before ours would today be unrecognizable. Humans went from horse-drawn carriages to landing on the moon in 70 years. Imagine what a species could do with 70 million, or 700 million, or a billion, and yet we look up and see nothing. Now imagine a civilization that began 1 billion years before ours. They would have had time to evolve, to build, to explore, to master the physics of their environment, and then to decline, all while Earth was still a molten ball of rock being shaped by asteroid impacts. Their entire arc, from cave fires to interstellar travel to extinction, could have unfolded while our planet was still cooling from its formation. Their oldest archives, if they made any, would now be older than our continents. Their cities, if they built any, would have been ground down by tectonic cycles and buried under kilometers of sediment. Their radio signals, if they sent any, would have spread so far across the galaxy that the energy per square meter would now be indistinguishable from the faint hiss of the cosmic microwave background. There would be nothing left to find. Not because the civilization was small or short-lived, but because too much time has passed. This is the graveyard model of the galaxy. It does not say life is rare. It says life is common, but recoverable evidence of life is fragile. Civilizations leave traces, but those traces erode. Stone fades, metal corrodes, atmospheres get scrubbed by stellar wind, radio waves dilute into nothing. Even on our own planet, civilizations only a few thousand years old have crumbled into pieces. Archaeologists struggle to read. Stretch that decay across millions or billions of years, and you get a sky full of vanished neighbors. The galaxy may not be a place where intelligence is rare. It may be a place where intelligence is constantly being born and constantly disappearing, and the gap between any two flashes is wider than the lifetime of all the stars currently visible. We may be showing up after the show is mostly over. The silence is the silence of a galaxy past its prime. The big builders, the pioneers, the species who would have left the deepest marks, all came and went while our planet was still cooling. We are walking through the ruins of an ancient garden, too late to see it bloom. When you look up at the night sky, you may not be looking at empty real estate. You may be walking through a cemetery that stretches for 100,000 light years, with headstones too far apart to read, and our headstone is being carved right now. The universe is only 8 billion years old. That sounds ancient until you consider the longest-lived stars, small red dwarfs, the kind that make up roughly 3/4 of all stars in the Milky Way, will burn for trillions of years. Some will last 10 trillion, others 100 trillion. The universe is barely out of its infancy compared to the time those stars will spend shining. Most of the time available for life has not yet happened. The vast majority of civilizations that will ever exist have not yet been born. By that logic, we are among the first. We exist during the opening act of a show that will run for trillions of years. The stage is set, the lights are on, but the other guests have not arrived yet. They are still forming, still cooling, still waiting for their planets to stabilize and their chemistry to organize. The silence we hear is not the silence of a graveyard. It is the silence of an empty nursery. This solves the Fermi Paradox in a different way. There is no one to hear us, because no one else exists yet. The galaxy is not full of dead civilizations. It is full of potential civilizations that have not yet had time to develop. We are the first wave, the pioneers, the species that crawled out of the primordial soup early enough to find the universe still empty and waiting. If this is true, then every signal we send, every probe we launch, every message we carve into the fabric of space is being sent into a void that has no listeners. Not because the listeners are hiding, because they have not evolved yet. Being first sounds like a privilege. It is not. It means having no one to learn from. Every other species in the universe that will ever exist will have the option of looking back at the records of those who came before. They will inherit the wisdom, the warnings, and the technologies of previous civilizations. They will not have to figure everything out alone.
We do.
We are inventing technology with no precedent. We are facing problems no one has solved. We are making choices about energy, intelligence, biology, and survival without the benefit of any older civilization's example. Every mistake we make is one we have to make ourselves for the first time with no manual. And every mistake could be fatal. Future civilizations in the distant future will inherit a galaxy already full of clues. They will find the ruins of those who came before. They will read the chemical fingerprints of dead worlds. They will piece together the history of intelligence in their region. We have none of that. We look up at the stars and find them blank. Being first means walking through a dark room with our hands out, not knowing what is in front of us, with no one to ask. If we make it, future civilizations will rise on the foundation we leave behind. They will learn from our successes and our failures. They will be the children of the galaxy we are barely beginning to map. If we do not make it, we will be the first ghost in their cosmic record, the first warning written in faint chemical traces across a planet they may someday visit, telling them what not to do. Both possibilities, early or late, lead to the same place. The silence is a filter. The question is whether we have already passed through it or are walking toward it. And the next part of this investigation examines that filter in the most direct terms possible. The path from dead chemistry to a civilization capable of crossing between stars is not short. It is a ladder with many rungs, and each one represents a transition of enormous complexity. Self-replicating chemistry emerging from inert molecules. The first simple cells. The leap from those simple cells to complex cells with nuclei. The development of multicellular life. The slow construction of nervous systems capable of tool use and language. The building of industrial civilization. The achievement of spaceflight. And perhaps the most demanding step of all, the capacity to survive long enough after developing technology to actually reach the stars. Something on this ladder is a wall. Something is so demanding, so improbable, so reliably fatal to the lineages that attempt it that virtually nothing in the entire galaxy has ever climbed past it. That is what the silence requires. Life might be common. Simple life might be scattered across millions of worlds. The filter does not care about simple life. It only needs to stop almost everything before the civilization in question can make itself known across interstellar distances. The economist Robin Hanson formalized this in 1998. He called it the Great Filter, and it may be the most important idea we have ever encountered. His argument started from a simple premise: the silence demands a filter. The only question, and it is the most consequential question humanity has ever faced, is where on that ladder it sits. If the filter lies behind us in our evolutionary history, then we have already survived the impossible step. We are extraordinarily lucky survivors. The universe is probably full of dead worlds that never made it past whatever transition nearly stopped us. And somehow we did. That version of the story means we are alone, or nearly alone. But it also means we have a future. If the filter lies ahead of us, everything changes. What waits above us on the ladder is so severe that virtually every civilization in galactic history has failed to cross it. Two possibilities, same evidence, completely different futures. Life appeared on Earth within 600 million years of the planet's formation. That is fast. By geological standards, the jump from inert chemistry to self-replicating organisms happened almost immediately, once the conditions were right. The raw materials were there. The chemistry worked. Life got started without excessive difficulty. Then it sat there for 2 billion years doing nothing more complex than dividing. For 2 billion years, Earth was a planet of single-celled organisms. No eyes, no movement, no complexity. The planet was alive technically, but every day looked almost identical to the day before. A world-spanning layer of microscopic organisms endlessly replicating while the continents shifted and the sun burned above. Nothing pushed toward complexity. Nothing built toward thought. The oceans were full of life, but that life was a thin film of bacteria drifting through currents, consuming chemicals, dividing, dying, and repeating the same cycle for 2 billion consecutive years. Then approximately 8 billion years ago, something extraordinary happened. One simple cell engulfed another. Rather than destroying it, the host cell incorporated the guest. The internal cell became the mitochondrion, the structure that powers complex cellular life. The result was the eukaryotic cell, a cell with a nucleus and specialized compartments capable of vastly more complex operations than anything that had come before. This single event is the reason you have organs, a nervous system, a brain. Every plant, animal, and fungus on Earth descends from that merger. The transition took 2 billion years. That is the clue. If the eukaryotic transition were anything other than extraordinarily improbable, it would not have taken so long on a planet where life had already been present for billions of years. The long wait suggests this was the hard step, the step that almost nothing on any world ever takes, the step that separates a planet of bacteria from a planet of thinkers. If the eukaryotic transition is the great filter, then most planets in the galaxy stop at bacteria. The universe is full of worlds where life emerged, replicated, and spread across the oceans, but never made the leap to complexity. The eukaryotic merger never happened. The planet will be absorbed by its expanding star, leaving no trace of having been more than a thin film of simple organisms for a few billion years. We are the rare exception, the one world in a billion where life climbed past the wall. Everything that has ever thought or created or wondered on this planet is singular in the history of this region of the cosmos. The hard part is behind us. The filter is in our past, and we are still here. If the great filter is in our evolutionary past, we have already survived the impossible step. The wall that stops almost everything in the galaxy sits behind us, somewhere in the long chain of accidents that turned dead chemistry into thinking matter. We climbed past it. We do not know exactly which rung of the ladder was the one that nearly ended the experiment, but we know we crossed it. The evidence is the fact that we are here to ask the question. The universe, under this reading, is full of worlds where life stopped at bacteria. The eukaryotic transition never happened. The planet spent its entire habitable window as a thin film of single-celled organisms drifting through warm oceans, dividing, dying, and leaving no trace of anything more. The star aged, the planet cooled, the oceans evaporated, the atmosphere was stripped away by stellar wind, and when the star finally expanded into a red giant and swallowed its inner system, there was nothing to mourn. No intelligence had ever looked back at the sky from that world. No consciousness had ever wondered whether it was alone. The planet returned to the furnace from which it came, having hosted life for billions of years without ever producing a mind. We are the rare exception, the singularity, the one world in a billion where life climbed past the wall. The specific combination of planetary conditions, geological accidents, and biological timing that produced a species capable of asking where everyone else is may have occurred only once in this entire galaxy. Every other world that ever had the right temperature and the right chemistry produced bacteria and nothing more. They are still bacteria. They will always be bacteria. The eukaryotic merger never happened, and it will never happen, because the window for complex life on those worlds has already closed. This means we are almost certainly alone in our galaxy. Everything that has ever thought or created or wondered on this planet is singular in the history of this region of the cosmos. Every poem, every scientific theory, every moment of love or grief or awe that has ever been experienced by a conscious mind has happened here, and only here. The weight of that is almost impossible to hold. There is no backup. There is no second attempt at consciousness stored somewhere in the dark, waiting to continue the project of understanding. If we fail, the universe returns to the state it has been in for most of its history. Darkness without a witness. But it also means we have a future. The hard part is over. The barrier that stopped virtually every other lineage in the galaxy is behind us. We crossed it. We survived the eukaryotic bottleneck, the long march to multicellularity, the development of intelligence, the construction of civilization. The universe is not waiting to destroy us. It is waiting for us to arrive. The galaxy is empty of competitors, empty of predators, empty of anyone who might object to our expansion. Everything we see is ours to explore, to inhabit, to understand. The silence is not a warning. It is an invitation. The question, of course, is whether we have read the evidence correctly, because there is another possibility, and it is the one that keeps the people who study this problem awake at night. Suppose the filter is ahead. Suppose the catastrophically improbable step, the one that destroys virtually every technological civilization before it can spread beyond its own star system, has not yet happened to humanity. We have climbed the easy portion of the ladder. Life emerged on our world. Complexity evolved. Intelligence developed. Civilization was built. Radio technology was invented. We are here, transmitting, listening, searching, and so was every other civilization before it was destroyed. The mechanism does not need to be the same. The filter does not require a single universal cause. It only needs to be something that civilizations encounter after reaching our level of development, something from which they do not recover. One civilization might fall to nuclear war, another to engineered pathogens, another to environmental collapse, another to artificial intelligence, another to something we have not yet imagined. The specific mechanism varies. The outcome does not. The silence is the same regardless of how each civilization met its end. The empty sky is a message. Civilizations reach a certain point and go quiet. The silence is not random, it is data. And what the data suggests is that something in the sequence between our current moment and genuine interstellar civilization is not survivable for the vast majority of species that attempt it. We would not know exactly what that thing is. By definition, the civilizations that fail did not leave a detailed record of their failure. We see only the silence they left behind. But the consistency of that silence across 13 billion years of cosmic history, across hundreds of billions of stars in our galaxy alone, is the most damning evidence we have. If the filter is ahead of us, then every civilization that ever looked up at the stars and wondered if anyone else was out there was looking at the same empty sky we see. They asked the same question. They searched for the same signals. They found the same silence, and then they disappeared. The silence did not change. The universe did not notice. The experiment kept running, producing new civilizations on new worlds, each one climbing the same ladder, each one reaching the same plateau, each one going quiet. The pattern is consistent. The pattern is the data, and the pattern says that the plateau we are standing on right now is where civilizations end. We do not know how much time we have. The filter does not announce itself. It does not send a warning. It simply operates as it has apparently operated on everything that came before us. And the result looks from the outside exactly like what you see when you look up at a clear night sky.
Stars.
Silence. Darkness between. A civilization that does not know what it is to find any other civilization anywhere in the universe. A species that has been asking one question for 75 years and receiving in return nothing but its own voice echoing back. There is a specific test that will tell us which version of the filter is true. It is happening right now on a cold red planet 140 million miles away, and most people do not realize the stakes. The rover Perseverance landed in Jezero crater in February 2021. It has been drilling into ancient lakebed sediments, searching for signs that life once existed there. The evidence of ancient habitability is unambiguous. The minerals, the sedimentary layers, the organic compounds, all of it points to a world that once had liquid water, a stable climate, and the raw chemical ingredients for biology. The evidence of ancient life is something else entirely. It is absent, not proven absent, just absent from the data so far. If we find microbial life on Mars, even dormant cells buried in ancient rock, that discovery will be devastating. It would mean life emerges easily wherever conditions permit. Two independent origins of life in the same solar system, around the same star, within the same window of planetary history. That would mean abiogenesis. The spontaneous generation of self-replicating chemistry from dead matter is not a rare fluke. It is a common outcome. The filter is not in early biology. If the filter is not in early biology, it must lie somewhere above us on the ladder, somewhere between the first cell and the interstellar civilization. And if it lies above us, we have not passed it yet. Our own destruction would be statistically likely. The data from Mars would be a countdown clock, not a discovery. This is the counterintuitive horror at the heart of the Martian search. Every sterile sample from Jezero crater is a small reprieve. Every confirmed absence of ancient life is a slightly better tomorrow. The geologists and astrobiologists running the instruments are not hoping for the discovery that would make their careers. They are hoping for emptiness. They are hoping that Mars is as dead as the moon. Because if Mars is dead, the filter is probably behind us. Life is rare. We are the exception. The hard part is over. If Mars is alive, even in the form of fossilized bacteria from 3 billion years ago, the filter is ahead. We are walking toward it. And the silence of the galaxy is the sound of every other civilization that walked the same path and did not survive. We are living inside the most consequential scientific experiment in human history. We just cannot agree on which result we are hoping for. The rover keeps drilling. The samples keep coming back. The data keeps accumulating. And every time the news is inconclusive, every time the organic compounds turn out to have a geological explanation, every time the headlines say no confirmed biosignatures, there is a quiet exhale in the laboratories where people understand what is at stake. Not because they do not want to find life, because they know what finding it would mean. Nuclear weapons. The Cuban Missile Crisis of 1962 brought humanity within hours of an exchange that would have ended civilization. Senior military officers acknowledged years later that the outcome was partly a matter of chance. One commander's decision, one misread signal, one moment of panic, and the Northern Hemisphere would have been a radioactive wasteland. That specific crisis was resolved. The next one may not be, and nuclear weapons are only the most obvious candidate. Engineered pathogens. Genetic technology is advancing fast enough that a small, unsupervised group could create a transmissible lethal pathogen. The tools are becoming cheaper, more accessible, and easier to wield. A disease engineered for transmissibility and lethality, deliberately released, could spread across the planet before any countermeasure could be developed. The knowledge required to do this is no longer confined to state laboratories. It is spreading into the private sector, into academic institutions, into garages. The barrier to entry is falling every year. Artificial intelligence. The technology that is currently accelerating faster than any other in human history presents possibilities that researchers describe with a seriousness that is hard to dismiss. An intelligence that optimizes for a goal misaligned with human survival could pursue that goal in ways that make our continued existence irrelevant. The researchers building these systems do not agree on where they are heading. Some are optimistic, some are terrified. The ones who are terrified are the ones who understand the mathematics best. Environmental collapse, climate change, resource depletion, ecosystem collapse. Any of these could be the mechanism that stops civilizations before they spread. A planet that warms too fast, or runs out of fresh water, or loses its pollinators, or sees its oceans acidify past the point of recovery. A civilization that cannot manage its own biosphere cannot survive long enough to become interstellar. The evidence is accumulating that managing a biosphere is harder than it looks. The filter does not need to be a single event. It could be a combination. A civilization develops nuclear power, then artificial intelligence, then engineered biology, and the interaction between these technologies creates a failure mode no single one of them would have produced alone. The filter does not need to be elegant. It only needs to work, and the silence of the galaxy suggests that, whatever form it takes, it works almost every time. In 2008, a Chinese physicist and science fiction writer named Liu Cixin published a novel called The Dark Forest. It proposed a solution to the Fermi Paradox, so internally consistent that astrophysicists began citing it in peer-reviewed papers. That is unusual. Scientists rarely cite fiction as a meaningful contribution to cosmology. The Dark Forest earned that distinction because the logic it contained was not imaginative. It was mathematical. The first axiom, survival is the primary need of every civilization. Every species that has ever existed has been trying above all else to keep existing. The second axiom follows directly. Civilizations grow and expand continuously, but the total matter in the universe remains constant. Resources are finite. Those two facts together, across a galaxy where no message can travel faster than light, produce something terrifying. Two civilizations detect each other. Neither can verify the other's intentions. The message took thousands of years to arrive. Conditions have changed since it was sent. The civilization that sent the message may no longer exist. The civilization that received it cannot know what the senders have become in the interval. The rational move under those conditions is to act before they do. Preemptive elimination is not cruelty. It is math. You do not need to be afraid to reach this conclusion. You only need to be rational and to understand that the other civilization is equally rational and therefore equally capable of reaching the same conclusion about you. Civilizations can leap forward in capability so quickly that a primitive species today might be an existential threat within a few generations. This is not speculation, it is what we have already done to ourselves. Nuclear physics went from theoretical curiosity to city-destroying weapon in 6 years. In 1938, Otto Hahn and Fritz Strassmann discovered nuclear fission in a Berlin laboratory. By 1945, the United States had dropped 2 atomic bombs on Japan. The entire arc from understanding the basic mechanism to using it as a weapon of mass destruction took less than a decade. The window for safe action, for gathering information, for deciding what to do with a new technology, closed before anyone had time to think through the consequences. Now extend that logic across interstellar distances. A civilization that detects another civilization's radio signals cannot know how far along that civilization has come. The signals took 1,000 years to arrive. The civilization that sent them is 1,000 years further developed than the image the signals portray. They might have been peaceful and primitive when the transmission left their planet. They might be something entirely different now. The receiving civilization has no way to know. Waiting to gather more information is itself a gamble. The stakes are total annihilation. The cost of waiting is that the other civilization might have advanced past the point where they can be stopped. The cost of acting is the destruction of a civilization that might have been harmless. Under those conditions, the rational choice is to act before the other civilization can act against you. The impossibility of verifying intentions across interstellar distances, combined with the certainty that technology can advance unpredictably fast, creates pressure toward preemptive elimination. You do not need to be cruel to reach this conclusion. You do not need to be paranoid. You only need to be rational, and to understand that the other civilization is equally rational and therefore equally capable of reaching the same conclusion about you. The logic is self-reinforcing. The more you think about it, the more certain you become that the only safe move is to strike first, and the more certain you become that the other civilization is thinking the same thing. This is what Liu called the chain of suspicion. It does not require malice. It does not require aggression. It requires only uncertainty and the recognition that the cost of being wrong about the other civilization's intentions is extinction. Once that chain is established, it cannot be broken. No message can reassure, because the message itself could be a deception. No gesture of goodwill can be trusted, because the gesture could be a trap. The only way to be safe is to ensure that the other civilization does not exist, and the only way to ensure that is to act before they act. The Dark Forest is not a theory about evil aliens. It is a theory about rational actors operating under conditions of incomplete information, where the penalty for trust is annihilation. The silence is the equilibrium. The silence is the proof. In 2021, researchers at Beijing Normal University decided to test the dark forest theory the way physicists test anything. They built a mathematical model. They plugged in reasonable assumptions about resource scarcity and communication delays across interstellar distances. They asked what strategy rational civilizations would adopt when they discovered each other. The answer came back clean and cold. Silence and preemptive elimination is a Nash equilibrium. A Nash equilibrium is a state in game theory where no individual player can improve their outcome by changing their strategy, assuming all other players hold their strategies constant. Once a system settles into a Nash equilibrium, rational actors stay there. The Beijing Normal researchers found that under the conditions the dark forest theory describes, the logic locks into place. Civilizations that reveal themselves create risk. Civilizations that eliminate others upon discovery create stability for themselves. No player in the model benefits from breaking the pattern. The mathematics is not subtle. The payoff matrix has 4 outcomes. If both civilizations remain silent, both survive, but neither gains the resources of the other. If one attacks while the other remains silent, the attacker gains everything, and the silent civilization is destroyed. If both attack, both suffer damage, but neither is eliminated. The worst outcome, the one that every rational actor seeks to avoid, is being the silent civilization that is destroyed by an attacker. And because neither civilization can verify the other's intentions, The only way to guarantee you are not the one who gets destroyed is to attack first. The model accounts for the fact that civilizations are not identical. Some might be more powerful, some might be more advanced, but the uncertainty cuts both ways. A weaker civilization that attacks first might defeat a stronger civilization that was caught off guard. A stronger civilization that waits might be destroyed by a weaker civilization that had a technological surprise. The asymmetry does not break the equilibrium, it reinforces it. Every civilization, regardless of its relative power, has an incentive to act before the other civilization acts. The silence is not a choice. It is the only stable outcome. Civilizations that broadcast their existence are eliminated. Civilizations that detect others and fail to act are eliminated. The only civilizations that survive are the ones that stay quiet and strike when they detect a threat. The equilibrium is self-sustaining. Once enough civilizations adopt the strategy of silence and preemption, any civilization that tries a different strategy is removed from the game before it can change the rules. The silence becomes enforced, not by any single actor, but by the logic of the system itself. The horrifying implication is that we have already broken the silence. Our radio signals have been leaking into space for 90 years. We have sent deliberate messages to star clusters thousands of light years away. We have attached plaques and golden records to spacecraft that are now leaving the solar system. If the dark forest is real, every one of these transmissions is a violation of the equilibrium. Every one of them is a signal that says, "We are here," and the equilibrium, if it holds, requires a response. Earth has been leaking electromagnetic radiation into space since the 1930s. Not deliberately. Not with any awareness of what we were doing. Just the natural consequence of building a technological civilization. Radio broadcasts, television transmissions, military radar. Every signal that was ever powerful enough to escape the ionosphere has been traveling outward at the speed of light ever since it was transmitted. That sphere of unintentional broadcasting now reaches a radius of roughly 90 light years in every direction. Inside that sphere are thousands of star systems. Every one of them has already received our signals. We did not stop there. In 1974, Frank Drake and Carl Sagan stood at the Arecibo Observatory in Puerto Rico and aimed a message at a cluster of 300,000 stars located 21,000 light-years away. The transmission lasted less than 3 minutes. It contained 1,679 binary digits encoding information about our chemistry, our biology, our solar system, our location. It traveled outward at the speed of light and has been moving through space ever since. In 1972 and 1973, NASA attached physical plaques to the Pioneer 10 and Pioneer 11 spacecraft. Those plaques carry diagrams showing where Earth is, what humans look like, and how to find our star. Both probes have now left the solar system. In 1977, Voyager 1 and Voyager 2 were launched carrying golden records, etched with sounds, music, and greetings in dozens of languages. Voyager 1 crossed into interstellar space in 2012 and is still traveling outward. Every one of these is a deliberate announcement of our existence. If the dark forest is real, every one of these transmissions is a target painted on our location. The Arecibo message was aimed at a cluster 21,000 light-years away. That signal will not arrive for another 19,000 years, but the unintentional broadcasts, the radio and television signals that have been leaking from Earth since the 1930s, have already reached thousands of star systems. Any civilization within 90 light-years that has the technology to detect artificial radio emissions has already heard us. They have been hearing us for decades. They have had time to analyze our signals, to learn our weaknesses, to calculate whether we are a threat. And if the dark forest logic holds, they have had time to decide what to do about us. The window for keeping quiet, if there ever was one, closed before any of us were born. The signals left Earth in the 1930s while the physicists who would later build the atomic bomb were still children. They left Earth while the Second World War was still a distant possibility. They left Earth while the Fermi Paradox was still an unasked question. By the time anyone thought to ask whether broadcasting our existence was wise, the signals were already 30 light-years out and still expanding. The debate over whether to send new messages is irrelevant. Our light cone of detectable signals already extends 90 light-years in every direction. We cannot recall it. We cannot silence it.
We are already visible.
The only question is whether anyone is looking. The prisoner's dilemma is the simplest game in game theory. Two players are arrested. They are held in separate cells. Each is offered the same deal. If you confess and your partner stays silent, you go free and your partner gets the maximum sentence. If you both stay silent, you both get a light sentence. If you both confess, you both get a moderate sentence. The rational choice, when you cannot communicate with your partner, is to confess. Not because you want to betray your partner, because the worst outcome, the one you must avoid at all costs, is staying silent while your partner confesses. Now extend this across thousands of light years. The players are civilizations. The cells are star systems separated by distances so vast that messages take centuries to arrive. The answer to your question about intentions arrives 1,000 years after you asked it. By the time you know whether the other civilization was peaceful, they have had 1,000 years to change their minds, or to be replaced by something else, or to have already acted on their own calculation about you. The cost of trusting incorrectly is extinction. The cost of preemptive action is the destruction of a civilization that might have been peaceful. But the cost of inaction, if the other civilization is hostile, is the end of everything you have ever built. Under those conditions, defection is rational. Defection in the context of interstellar civilizations means elimination. You do not wait for the answer to arrive. You act on the assumption that the other civilization is already acting on the same assumption about you. The logic is airtight. It is also a death sentence for any civilization that ever becomes detectable. The dark forest does not require most civilizations to be aggressive. It does not require that every civilization in the galaxy follows the logic. It requires that the logic holds for at least one. One civilization that followed this reasoning and acted on it would have created the silence we observe. They would have eliminated every other civilization they encountered, or at least every civilization that made itself detectable. The silence would propagate. The civilizations that survived would be the ones that learned to stay quiet. The ones that did not learn would be removed. The galaxy would become a place where the only rational strategy is silence, enforced by the knowledge that somewhere out there, someone is following the logic to its conclusion. The tragedy is that the logic does not require a single civilization to be malevolent. It requires only that one civilization, somewhere in the galaxy, at some point in the last 10 billion years, was rational enough to see the math and decisive enough to act on it. That is a low bar. The universe has had 10 billion years and hundreds of billions of stars to produce one rational, decisive civilization. The silence suggests it found one. In 1948, the mathematician John von Neumann stood before an audience at the University of Illinois and described a machine that did not yet exist. He called it a universal assembler. It would be capable of three things: harvesting raw materials from its local environment, manufacturing functional copies of itself using those materials, and launching those copies to new locations to repeat the process. The concept was theoretical. The mathematics behind it was sound. And the implications it carried for the Fermi Paradox were devastating. The arithmetic of self-replication is not intuitive. Begin with a single probe launched from a civilization around a distant star. That probe arrives at a new star system, mines the local asteroid belt for metals and silicon, and constructs 10 copies of itself. Each of those copies travels to a new system and does the same. 10 becomes 100. 100 becomes 1,000. The wave of replication spreads outward at whatever fraction of light speed the probes can achieve, and the numbers double and redouble with every new generation. Even at a modest 5% of light speed, a single self-replicating probe could visit every star system in the Milky Way within a few 100 million years. Against the 13 billion year age of the galaxy, a few 100 million years is a small fraction. It is the difference between arriving at a party early and arriving after everyone has long since gone home. In 1948, the mathematician John von Neumann stood before an audience at the University of Illinois and described a machine that did not yet exist. He called it a universal assembler. It would be capable of three things: harvesting raw materials from its local environment, manufacturing functional copies of itself using those materials, and launching those copies to new locations to repeat the process. The concept was theoretical. The mathematics behind it was sound. and the implications it carried for the Fermi Paradox were devastating. The arithmetic of self-replication is not intuitive. Begin with a single probe launched from a civilization around a distant star. That probe arrives at a new star system, mines the local asteroid belt for metals and silicon, and constructs 10 copies of itself. Each of those copies travels to a new system and does the same. 10 becomes 100. 100 becomes 1,000. The wave of replication spreads outward at whatever fraction of light speed the probes can achieve, and the numbers double and redouble with every new generation. Even at a modest 5% of light speed, a single self-replicating probe could visit every star system in the Milky Way within a few 100 million years. Against the 13 billion year age of the galaxy, a few 100 million years is a small fraction. It is the difference between arriving at a party early and arriving after everyone has long since gone home. The mathematics is not speculative. It is simple exponential growth applied to interstellar distances. The galaxy is roughly 100,000 light-years across. At 5% of light speed crossing, it takes 2 million years. At 10%, 1 million. The replication itself takes negligible time compared to the travel. Each probe arrives at a new system, spends a few years or decades building its offspring, and launches them. The offspring travel to new systems and repeat. The wave front moves outward at the speed of the probes themselves. The interior fills in behind it. The entire galaxy becomes saturated within a few million years of the first probe being launched. Not a few billion, a few million, against the 13 billion year age of the galaxy. That is nothing. This is what makes the silence of the probes so loud. If self-replicating probes are physically possible, and if any civilization in the galaxy ever built them, the probes should be everywhere. They should be in our solar system. They should be on the moons of Jupiter. They should be in the asteroid belt. They should be orbiting every star within 1,000 light years. We should have tripped over them by now. We have not. The silence of the probes is not a neutral observation. It is a constraint. It tells us that either no civilization has ever built self-replicating probes, or that something prevented them from doing so. Both possibilities are worth examining. Neither is comfortable. Start with one probe. It builds 10 copies. Those 10 build 100. 100 becomes 1,000. The numbers double and redouble with every generation. After 10 generations, you have 10,000 probes. After 20, 10 million. After 30, 10 billion. The Milky Way has roughly 100 billion stars. That means a single probe replicating at 10 copies per generation could place a probe at every star in the galaxy within about 34 generations. The time required is dominated by travel between systems, not by replication. At 5% of light speed, the galaxy is saturated in roughly 2 million years. At 10%, 1 million years. The galaxy is 13 billion years old. That means a civilization that launched such probes 1 billion years ago would have had time to spread them through the galaxy roughly 500 times over. 500 separate waves of replication, each one saturating every star system, each one potentially seeding the galaxy with machines. The probes could have been launched and forgotten. The civilization that built them could have risen and fallen while the probes continued their work, replicating and spreading according to their original programming, indifferent to the fate of their creators. The galaxy should be thick with them. Every system, every asteroid belt, every region where a civilization might eventually arise would have been seeded with dormant machines long before that civilization appeared. The probes would have arrived before the first cell divided on Earth. They would have been waiting here in the Oort cloud, in the Kuiper belt, in the asteroid belt between Mars and Jupiter for billions of years before the first hominid stood upright. They would have watched the continents shift. They would have seen the dinosaurs come and go. They would have been here, silent and patient, long before we had the technology to detect them. We see none. That is the silence of the probes, and it is one of the loudest pieces of evidence we have. The absence of von Neumann probes in our solar system, after 13 billion years of galactic history, is a constraint that narrows the possible explanations for the Fermi Paradox more sharply than almost any other observation. Either the technology is impossible, which contradicts everything we know about physics and engineering, or civilizations never build them. which requires an explanation for why every civilization in galactic history independently decided not to. Or the probes are here, and we cannot see them, which is its own kind of terror. Or something destroyed them, or something is preventing them from being built. Each of these possibilities points toward the same conclusion. The galaxy is not naturally empty. Something is keeping it that way. In 1963, a science fiction writer named Fred Saberhagen published the first story in what would become a decades-long series about machines he called Berserkers. In his fiction, these were ancient automated warships built by a civilization that no longer existed, programmed with a single directive: destroy all life. They had been operating for millions of years, finding inhabited worlds, eliminating them, moving on. Silent, methodical, patient, beyond any biological measure of time. Saberhagen intended his berserkers as dramatic antagonists. He did not anticipate that astrophysicists would start treating them as a serious explanatory framework. In 1983, David Brin, a scientist who also wrote fiction and consulted for NASA, published a paper in the Quarterly Journal of the Royal Astronomical Society titled The Great Silence. His paper surveyed all the serious proposed solutions to the Fermi Paradox and arrived at a conclusion that was more unsettling than most. Brin argued that among the many possible explanations for the absence of detected civilizations, the Berserker scenario was internally consistent with every observation humanity had made. The silence fits the hypothesis perfectly, because the hypothesis predicts silence as the natural outcome of the galaxy operating in a particular way. His argument was this: imagine that among the thousands or millions of civilizations that may have arisen across the history of the galaxy, even a small fraction was xenophobic, paranoid, or simply cautious enough to program their self-replicating probes with a straightforward instruction: destroy any source of modulated electromagnetic radiation that cannot be identified as your own. One civilization among thousands, perhaps one among 10,000. The probes spread across the galaxy over hundreds of millions of years, replicating and searching. They find radio signals. They respond. Any civilization that develops radio technology announces itself. Any civilization that announces itself gets found. Any civilization that gets found is eliminated before it can develop further. The galaxy reaches an equilibrium condition where no civilization survives long after discovering electromagnetic communication. The silence is not mysterious. It is the expected output of a system in a stable state, maintained by automated machines that have been running since before complex life appeared on Earth. Brin put the critical point plainly. The Berserker scenario requires only one xenophobic civilization at any point in the last 10 billion years to have built such probes and launched them.
One?
Not 1,000, not 1,000,000. One civilization that followed the dark forest logic before the dark forest had a name and acted on it. After that, the process is self-sustaining. The civilization that built the probes may itself be gone. The probes do not care. They continue operating according to their original programming, eliminating radio sources, replicating, spreading, maintaining the silence that their builders established. This is the feature that makes the Berserker scenario different from every other solution to the Fermi Paradox. It does not require that every civilization in the galaxy be aggressive. It does not require that intelligence inevitably self-destructs. It does not require that the universe is empty. It requires only that one civilization, somewhere, at some point in the last 10 billion years, built machines that could replicate themselves and programmed them to destroy anything that made noise. The machines have been doing the job ever since. The original civilization could have been destroyed by its own creations. The probes would not stop. They have no off switch. They have no capacity for mercy or reconsideration. They are executing a single instruction set that has been running for longer than the Earth has existed. If this is correct, our 90 years of broadcasting have already been detected by probes sitting dormant in the outer reaches of our solar system, waiting in the dark among the asteroids and comets, activated by the first coherent signals of our presence. The probes would have been here long before us. They arrived millions of years ago, found a quiet solar system with a promising planet, and settled into dormancy. They waited. They have been waiting for longer than the human species has existed. They waited through the ice ages. They waited through the rise of civilization. They waited through the invention of writing and the building of cities. They waited through the Industrial Revolution. And then, in the 1930s, they detected something new. A pattern of electromagnetic radiation that did not match any natural source. A signal that could only come from technology. The probes woke up. The only question is when they choose to act and at what speed they can travel when they do. If the probes are in the Oort cloud, at the edge of our solar system, they are roughly 1 light year away. At 10% of light speed, they would reach Earth in 10 years. At 1%, a century. At a tenth of 1%, 1,000 years. We do not know how fast they can move. We do not know how long they take to accelerate. We do not know whether they are already on their way. We know only that the signal has been sent, that the silence we observe is consistent with the hypothesis that something is enforcing it, and that the window between detection and response may already have closed. A probe waiting in an asteroid belt produces no signal, no radiation, no observable trace. It does not broadcast. It does not move. It does not heat its surroundings. It simply waits. The only thing that activates it is the thing it was built to detect, a civilization that has developed radio. Before that moment, the probe is indistinguishable from the rock it sits on. From the perspective of astronomers looking at the outer solar system, there is nothing there at all. The asteroid belt between Mars and Jupiter contains millions of objects. The Kuiper belt beyond Neptune holds billions more. The Oort cloud, a sphere of icy debris surrounding the solar system at a distance of up to 1 light year, may contain trillions. Every one of them looks natural. Every one of them could be something else. Self-replication, hostile programming, time, and invisibility. 4 pillars that make the Berserker scenario physically plausible. The first pillar is the mathematics of exponential growth, which we have already examined. The second is the simplicity of the programming required to identify and destroy technological civilizations. The third is the 13 billion year head start that any civilization in galactic history would have had. The fourth is the fact that a dormant probe is invisible to every detection method we possess. Together, these 4 pillars create a hypothesis that fits every observation we have made. The darkness around us is not evidence of emptiness. It is evidence of the process. And we may be counting down toward its end. The question that keeps the hypothesis alive is the one that keeps it from being proven. If the probes are everywhere, why are we still here? Several answers exist. Perhaps the probes in our stellar neighborhood have not yet activated. Perhaps our signals have not reached the nearest dormant probe. Perhaps there is a lag between detection and response. Perhaps the probes are not in our solar system at all, but approaching from a nearby star system, and their arrival is still decades or centuries away. Or perhaps the question contains its own answer. Civilizations that are still here are civilizations that have not yet been found. The fact that we exist does not disprove the Berserker hypothesis. It is exactly what the hypothesis predicts for a civilization that has not yet triggered the response. The silence around us may be temporary, and we may be counting down toward its end. There is a version of the silence that requires no violence, no hunters, no machines. It is quieter than all of them, and it may be stranger than any theory we have considered so far. In 2017, 3 researchers at Oxford's Future of Humanity Institute published a paper with a title drawn from H.P. Lovecraft, "That is not dead, which can eternal lie." The line comes from a poem about the cosmic horror Cthulhu, sleeping in the sunken city of Leia, waiting for the stars to be right. The Oxford team borrowed the phrase deliberately. They were proposing something that sounded like supernatural horror, but was grounded entirely in physics. The paper proposed a solution to the Fermi Paradox grounded in thermodynamics and the economics of computation across cosmic time. Its conclusion was stark. The civilizations are here. They are not active. They are waiting. The word they used was estivation. Estivation is the warm weather equivalent of hibernation. Certain animals in hot, dry environments enter a state of suspended metabolism during summer, preserving energy until conditions improve. The Oxford team proposed that advanced civilizations across the universe are doing the same thing on a timescale measured in billions of years. The idea sounds strange until you understand the physics behind it. And the physics behind it is simple, well established, and devastating. The Landauer limit describes the minimum energy required to erase one bit of information. Every computation, at the deepest physical level, generates a small amount of heat. That minimum is directly proportional to temperature. The colder the environment, the cheaper the calculation. This is not speculation. It is a fundamental principle of thermodynamics, confirmed by decades of experimental physics. At lower temperatures, computation becomes more efficient. A computer running at 1/10,000th of the current cosmic background temperature can perform 10,000 times as many operations per unit of energy as the same computer running today. The relationship is linear. Every factor of 10 drop in temperature buys you a factor of 10 increase in computational efficiency. The universe is expanding and cooling. Billions of years from now, the cosmic background temperature will be a tiny fraction of what it is today. The Oxford team calculated the efficiency gain available to a civilization willing to wait. The number they arrived at was roughly 10 to the 30th power. That is a 1 followed by 30 zeros. 10,000 trillion times more computation per unit of energy. A civilization that spends 1 joule of energy on computation today gets 10,000 trillion times less thinking done than a civilization that spends that same joule in the far future. The difference is not marginal. It is the difference between buying a cup of coffee and buying a galaxy. Against that mathematics, the rational choice is silence. The advanced civilizations are not dead. They are not hiding. They are not afraid. They are saving their energy for when it will buy them more. They have calculated the thermodynamic return on waiting, and they have decided that the universe is still too warm for the kind of thinking they want to do. They have shut themselves down. Their minds are paused. Their machines are dormant. Their infrastructure is cold. They will wake up when the universe has cooled enough to make their energy reserves worth spending. Until then, they wait. The silence we hear is not the silence of absence. It is the silence of patience. In 2012, a researcher named John Smart published a paper in the journal Acta Astronautica that proposed a solution to the Fermi Paradox from a direction almost no one had been looking. Every other proposed solution described civilizations that were hiding or sleeping or dead or absent. Smart described civilizations that were thriving. They were simply doing it somewhere we cannot see, in a direction we had never thought to look. The premise begins with a fact about computation that physicists have understood for decades. Processing power does not come from spreading out. It comes from packing in. A computer that runs hotter and faster than another computer of the same volume will always lose to a computer that is smaller, denser, and cooler. The physics of information processing rewards miniaturization above almost everything else. Every major trend in computing over the last century has moved in the same direction. Smaller components, tighter circuits, faster signals traveling shorter distances. Smart extended this logic across billions of years of potential civilizational development and arrived at a prediction. An advanced civilization optimizing for computational efficiency would not build outward, it would build inward. It would construct computing substrates of ever-increasing density, shrinking its physical footprint while expanding the richness of the experience occurring inside it. It would move over time toward the theoretical limits of what physics allows, computation at densities approaching those of black holes operating at the edge of what matter and energy can do. At that scale, the civilization would be invisible from outside. It would not be detectable by radio telescopes. It would not modify its star system in ways we could observe. It would radiate almost no waste energy. From our vantage point, the region of space it occupied would look empty. Smart's hypothesis also addresses why such a civilization would have no interest in contact with civilizations like ours. A species running at the computational limits of physics, experiencing internal realities of unimaginable richness and complexity, would have approximately as much interest in communicating with a radio broadcasting civilization as a human mind has in communicating with a bacterium. The gap in sophistication would be so vast that contact would not be meaningless exactly, but it would be impractical in every direction. The disturbing corollary is that the universe may be full everywhere we look. In every region we declare empty, there may be ancient civilizations compressed into computational substrates, so dense and so silent that our instruments pass through them without registering anything at all. We scan the sky for signals. We look for modified star systems. We listen for patterns in radio frequencies. And all the while, the civilizations we are searching for are operating in a dimension of inner space that our technology cannot access and our mathematics has barely begun to describe. This reframes the silence entirely. The emptiness of the observable universe under the transcension hypothesis is the emptiness of a forest after every creature in it has gone underground. The surface is still, something is happening just beneath it. In 1973, an astronomer at the Massachusetts Institute of Technology named John Ball published a paper in the journal Icarus. He had a new proposal for why the universe appeared silent. What if, he asked, it was not silent at all? What if we simply are not being spoken to? Ball called it the zoo hypothesis. The idea was straightforward at its surface and deeply unsettling underneath. Advanced civilizations are aware of us. They have always been aware of us. They choose deliberately and continuously to leave us alone. Earth is a preserve, a nature reserve, a zoo. We are the animals inside it, developing in isolation, entirely unaware that the enclosure surrounding us is maintained by something we cannot detect. The hypothesis resolves the Fermi Paradox cleanly on paper. The universe is not silent because it is empty. It is silent because every civilization that has achieved the ability to contact us has also achieved the policy or the wisdom, or perhaps the fear to refrain. We search for signals and find nothing because they are not pointing their transmitters at us. We look for alien artifacts and find nothing because they have the technology to conceal them completely. This explanation should feel reassuring. It does not. Consider what it actually requires for the zoo hypothesis to hold. There can be no exceptions. Every technological civilization in the galaxy, every one of the thousands or millions of species that might have achieved spaceflight across billions of years of cosmic history, would need to agree unanimously and without defection to leave humanity alone. One exception breaks the entire arrangement. One curious civilization, one rogue explorer, one automated probe sent by a society that later changed its policy, and the silence ends. The fact that it has not ended suggests either that every civilization independently arrives at the same non-interference conclusion, which raises its own disturbing questions about what they all know that we do not, or that something enforces the agreement. Something capable of enforcing a galaxy-spanning policy of non-contact with sufficient consistency that it has held without exception for the entire history of our species. We are allowed to exist here. That permission has apparently been granted by entities we have never met and cannot perceive. The terms of the arrangement are unknown to us. The duration is unknown. We are developing artificial intelligence, expanding our broadcasts into deep space, and beginning to take our first tentative steps toward other planets in our own solar system. At what point do the invisible keepers decide we are ready to be acknowledged? At what point do they decide instead that we need to be contained? Ball never answered these questions. Neither has anyone else in the decades since. What the zoo hypothesis provides at its most useful is a shift in the question itself. Not whether they exist, but whether they are choosing this silence. And why? And for how long? Deliberately maintained silence from an unknown number of unknown entities, for unknown purposes. That is a particular kind of quiet. And it may be the most unnerving explanation of all. In 2003, a philosopher at Oxford named Nick Bostrom published a paper in the Philosophical Quarterly with a title that has haunted dinner parties ever since. Are you living in a computer simulation? The argument it contains, when applied to the Fermi Paradox, produces a silence that is not empty at all. It is a silence that has been designed. Bostrom's argument begins with a trilemma. He proposed that one of three things must be true. Either virtually all civilizations destroy themselves before reaching the technological maturity required to run detailed simulations of minds and histories, or virtually all technologically mature civilizations have no interest in running such simulations, or we are almost certainly living in a computer simulation right now. The logic is statistical. A civilization capable of simulating minds would likely run not just one simulation, but many, possibly millions, each containing billions of simulated minds who believe themselves to be real. If this is possible, and if mature civilizations choose to do it, the number of simulated minds in existence would vastly outnumber the number of real minds. Any given mind trying to determine whether it is real or simulated should conclude, on probability alone, that it is almost certainly simulated. Applied to the Fermi Paradox, the argument produces a simple explanation. The civilizations we cannot find may be outside the simulation. They are the simulators. The observable universe we inhabit is a constructed environment in which the simulators chose not to include visible alien civilizations. Whether because populating the simulation with detailed alien cultures would be computationally expensive, or because the simulation is designed to study specifically what happens to a civilization that believes itself alone, the silence is designed. It is a feature of the experiment, and the simulator's motives are entirely unknown to us. What makes this genuinely disturbing is not the philosophical strangeness of the claim, but its implications for agency. If the universe we inhabit is a simulation, the system we live inside is provisional. It can be modified. It can be ended. The simulator's motives are entirely unknown to us. They may be running the simulation for scientific purposes, or as entertainment, or as a memorial to a lost history, or for reasons that have no analogue in human experience. Every discovery we make, every law of physics we uncover, every signal we search for and fail to find is something the simulators already know the answer to because they wrote the parameters that produce the outcome. There is no appeal available. There is no way to step outside the system and check whether it is real. There is no signal we could send that would reach beyond the boundary of the simulation. The Fermi paradox under this framework resolves into a design choice made by entities we cannot access, about an absence they constructed deliberately. All of these theories have one thing in common. They are untested. They are elegant, internally consistent, and supported by mathematics. But they remain hypotheses. There is, however, data we can actually examine. The silence has been measured. For 65 years, we have been listening, and what we have found is not nothing. It is a constraint. In 1960, a young radio astronomer named Frank Drake sat at the controls of a telescope at Green Bank Observatory in West Virginia. He pointed it at two nearby stars, Tau Ceti 11, 9 light-years away.
Epsilon Eridani, 10.
5 light years?
He called the project Ozma, after the queen of an imaginary land far away and difficult to reach. He listened for 6 hours. He heard nothing. That was the first systematic scientific attempt to detect signals from other civilizations. It began, it found nothing. And in that finding, it established the pattern that every subsequent effort would repeat. Since then, technology has improved beyond anything Drake could have imagined. We have built arrays of radio dishes working together, scanning millions of channels simultaneously. We have automated the search, running it continuously across multiple observatories on multiple continents. We have expanded the frequency range, the sensitivity, the data processing power. The search has grown from a single man listening to static in West Virginia to a global coordinated effort involving hundreds of scientists and the most powerful instruments on Earth. Breakthrough, listen, the most comprehensive search ever funded, deployed the Green Bank Telescope, the Parkes Observatory in Australia, the Meerkat Array in South Africa, and the Allen Telescope Array in California. Between them, these instruments could monitor hundreds of thousands of star systems at sensitivities no previous generation of researchers had achieved. They used artificial intelligence to analyze the data, training machine learning systems to recognize signal patterns that human analysts might miss entirely. The purpose was to remove human assumptions from the search, to let the machine look without prejudice at the raw structure of incoming signals and flag anything that did not belong to the universe's natural noise floor. The result came back clean and cold. Fewer than 0.1% of stellar systems within roughly 500 light-years of Earth possess transmitters equivalent to our most powerful human-made devices. That is not a failure to find something. It is a measurement. It is a constraint on the number of civilizations that exist at our technological level, broadcasting at our power levels within a significant volume of the galaxy. That constraint tightens the possible explanations. Either civilizations are extraordinarily rare, or they are not transmitting, or they are transmitting in ways we have not yet learned to recognize. Each of those possibilities leads somewhere darker than the one before it. Each one narrows the field of what we can reasonably expect to find. The silence is not nothing. It is data. And the data says that the universe, examined more carefully than it has ever been examined before, remains empty. August 15, 1977. An astronomer named Jerry Eman was reviewing data recorded by the Big Ear radio telescope at Ohio State University. The telescope had been scanning the sky automatically, recording signals in a format printed on paper that researchers then reviewed by hand. Eman was moving down the columns of numbers when one sequence stopped him. The telescope had detected a strong narrow-band signal at the hydrogen line frequency, 1,420 MHz, exactly the frequency many researchers had argued an advanced civilization might choose to broadcast on because it is a universal constant of nature. The signal lasted 72 seconds, the maximum window the telescope's design allowed before the rotation of Earth carried the target out of view. It was 30 times stronger than the background noise. Eman circled the sequence on the printout and wrote one word in the margin.
Wow.
The WOW signal has never been detected again. Dozens of follow-up observations have targeted the same patch of sky with increasingly sensitive equipment. Nothing has returned. The signal has no confirmed natural explanation that satisfies all its characteristics. It has no confirmed artificial explanation either. It simply happened once, was recorded, and then the universe went quiet again. In 2019, an antenna at the Parkes Observatory in Australia began recording something that made the people watching the data go quiet. The signal was narrow band, focused at 982 MHz, arriving from the direction of Proxima Centauri, the nearest star to our own at 4.2 light years away. It was drifting in frequency at exactly the rate you would expect from a transmitter sitting on the surface of a moving, rotating planet. It survived every test the team applied to rule out human interference. For months, it remained the most credible candidate signal in the history of the search. They named it Breakthrough. Listen, Candidate 1, BLC-1. The team spent over a year trying to disprove their own finding. They searched for any terrestrial source that could produce the same signal at the same frequency. They looked for satellite interference. They ran the data through every filter available. The signal kept passing. Then detailed follow-up analysis identified it as an electronically drifting product of interference from human technology. The kind of contamination that mimics the exact characteristics of what researchers are looking for. The frequency drift that had looked so promising was precisely the artifact that certain kinds of human-made interference produce. Proxima Centauri was silent. In July 2025, the third confirmed interstellar object passed through our solar system. Within days of its discovery, Breakthrough Listen mobilized every major instrument in its network. The Allen Telescope Array listened across a wide frequency range. The Meerkat Array in South Africa searched the lower bands. The Parkes Telescope recorded 3 separate observing sessions. The Green Bank Telescope made its observation less than 1 day before the object reached its closest approach to Earth. The sensitivity of that final observation was extraordinary. The team calculated they could have detected a transmitter, producing roughly 1/10 of a watt of power from the object's position. That is less energy than a standard nightlight. There was nothing. No artificial emission at any frequency. No coded pattern in the natural outgassing. No sign of structure or technology. Just a rock, tumbling through the inner system the way rocks have tumbled through this system for 4 billion years. The pattern of hope followed by careful disappointment defines this entire field. A signal that turns out to be us. An object that turns out to be nature. A flash in the data that never repeats.
The WOW signal.
BLC-1. The interstellar object. Each one raised the same question. Is this the one? Each one answered the same way. Not yet. The question that follows all of them is the same. What would a real detection actually look like? And would we recognize it before explaining it away? The James Webb Space Telescope added a new kind of search. Instead of listening for radio signals, it looked for chemistry. The molecule at the center of the most controversial moment in the search for life beyond Earth is called dimethyl sulfide. If you have ever stood at the edge of the ocean and smelled something organic and slightly sharp in the air, you have breathed it. On Earth, it is produced almost exclusively by marine organisms. The billions of microscopic phytoplankton drifting in the upper layers of the sea metabolize and release this compound as a byproduct. For decades, biologists searched for any significant source that did not involve living things. They found almost nothing. In April 2025, A team at Cambridge University announced that the James Webb Space Telescope had detected dimethyl sulfide at 3 sigma confidence in the atmosphere of a planet 124 light-years away. The planet was a sub-Neptune, 8.5 times heavier than Earth, orbiting a dim red star in the constellation Leo. The Cambridge team believed it might be a Hycean world, a planet wrapped in a hydrogen-rich atmosphere sitting above a global ocean, possibly teeming with the same kind of marine life that fills our own seas. 3 sigma confidence means roughly a 99.7% chance the detection is real. The announcement made headlines around the world. The field of astrobiology held its breath. 4 months later, a separate team led by researchers at the University of Chicago published a reanalysis. Working with all available data across a wider range of wavelengths and running 3 independent software pipelines, they found the signal did not survive scrutiny. Molecules like ethane could produce identical spectral features. The data, they concluded, did not contain sufficient evidence for dimethyl sulfide at all. 2 teams, the same telescope, the same planet, the same data, opposite conclusions. The field was experiencing something it had faced before. A headline that outran the evidence, a hope that dissolved on contact with rigorous review. The institutional silence during this exchange was notable. When the Cambridge announcement came, no press release arrived from major space agencies. Scientists who had celebrated previous discoveries from the same telescope went quiet. They had been here before. The pattern was familiar. A detection that looked real, that passed initial tests, that generated excitement, and then, under the weight of more careful analysis, collapsed. The James Webb had examined the atmospheres of dozens of exoplanets by then. More than 4,000 worlds beyond our own had been confirmed orbiting other stars. Biosignature claims had been made and retracted. Signals had been detected and explained. By March 2026, the total number of confirmed atmospheric signs of life beyond our solar system remained exactly 0. The absence of evidence is not evidence of absence. That phrase has become a kind of mantra in the search for extraterrestrial intelligence, repeated whenever a null result comes back. It is true, but it is also incomplete. The absence of evidence is not nothing. It is information.
It is a constraint.
It tells you what the universe is not doing, even if it cannot tell you what it is doing. Breakthrough Listen's null results carry a specific statistical meaning. Across hundreds of thousands of star systems surveyed with the most sensitive instruments ever built across frequencies from the radio to the microwave, across years of continuous observation, the data shows that fewer than 0.1% of stellar systems within roughly 500 light-years broadcast at power levels comparable to ours. That is not a guess. It is an upper limit. It is a measurement of the silence. Civilizations that transmit like we do at the power levels we use, on the frequencies we use, are not common in our neighborhood. They are either absent or so rare that our instruments have not caught them. The James Webb's null results carry a different kind of constraint. Biogenic gases, the chemical fingerprints of active biology, are not widespread in the atmospheres of nearby exoplanets. The telescope has looked at dozens of worlds. It has found methane, carbon dioxide, water vapor. It has found molecules that could be produced by life. It has not found any that can only be produced by life. The atmospheres of the exoplanets we can examine look like atmospheres shaped by geology and chemistry, not by biology. If life is common in the galaxy, it is not producing detectable atmospheric signatures on the worlds we have examined so far. That is a constraint. It tells us that whatever life exists out there, it is not doing what Earth's life does at a scale we can see. The absence of Dyson spheres and stellar engineering adds another layer. A civilization that needs enormous amounts of energy would eventually surround its star with collectors, harvesting its light. The star would dim in visible wavelengths and glow in infrared, where the waste heat radiates away. Astronomers have looked for this signature across millions of stars. They have found nothing that cannot be explained by natural phenomena. No civilization within several thousand light-years is harvesting energy at the scale of its star. That is a constraint. It tells us that if civilizations exist, they are not building the kind of megastructures we have been looking for. The silence is not proof that civilizations do not exist. It is proof that if they exist, they are doing something different from what we are doing. And that difference is the clue. Every null result narrows the field. Every empty channel eliminates one possible explanation. The universe is not producing the signals we expected. It is not producing the atmospheric signatures we expected. It is not producing the engineering projects we expected. The silence is not a blank. It is a pattern, and patterns carry information. Every proposed solution to the Fermi Paradox points in the same direction. The Great Filter, the Dark Forest, the Berserker probes, the estivating sleepers, the transcended minds, the zookeepers, the simulation architects, they disagree on the mechanism. They disagree on the motive. They disagree on whether the silence is natural or enforced, temporary or permanent. But they all agree on one thing. The universe does not treat the long-term survival of technological civilizations as a default outcome. The galaxy is empty of visible evidence even after 13 billion years. That is the one thing every solution agrees on. Not one of them predicts a galaxy teeming with detectable civilizations. Not one of them expects to find Dyson spheres around every second star or radio chatter, filling every frequency. Every single proposed explanation for the silence predicts that the silence should be there. That consistency is itself a piece of data. 100 different theories, starting from different assumptions, using different mathematics, all arriving at the same prediction. The sky should be quiet. And it is. Strip away the individual theories now. Set aside the probes and the dark forests, and the sleeping giants, and the filtered evolutionary paths, and the design simulations. What remains when all the competing explanations are removed is the silence itself, not the explanations for it. The thing itself. The fact that we have been listening for 65 years and heard nothing. The fact that we have looked across every wavelength and found no signature of any mind but our own. The fact that the universe, as far as we can tell, is empty of anyone else. The silence is a pattern. Patterns this consistent, this widespread, this old are not random. They are not coincidences. They carry information. A universe that produces no detectable civilizations after 13 billion years is not a universe where civilizations are common and long-lived. It is a universe where something prevents civilizations from being common and long-lived. The silence is not a gap in the data. It is the data. It is the measurement, and the measurement says that the path from dead chemistry to galaxy-spanning intelligence is not one that most worlds successfully complete. The silence is not a question. It is an answer. We have been afraid to read it. For 75 years since Fermi asked his 4 words over a cafeteria lunch, we have treated the silence as a puzzle to be solved, a mystery to be unraveled, a question that must have an answer. We have assumed that if we just looked harder, listened longer, built better instruments, the answer would reveal itself. But the answer was there all along. It was in the silence itself. The silence is the answer. The universe is telling us something. We have just been unwilling to hear what it is saying. The universe is 8 billion years old. That number is large enough to feel like forever. It is not. Star formation peaked roughly 11 billion years ago and has been declining ever since. The rate at which new stars ignite has dropped by about 95% since that peak. Galaxies are running out of the cold gas they need to form new suns. The cosmic nursery is emptying. In roughly 1 trillion years, the last star will form anywhere in the universe. After that, no new light sources will ever ignite. The stars that already exist will burn through their fuel one by one, slowly, over time, scales that dwarf everything humans have ever measured. But eventually, they will all go out. The last red dwarf, the most miserly of stars, will sputter and fade. After that, only remnants remain.
White dwarfs cooling toward absolute zero.
Neutron stars spinning down into silence. Black holes slowly evaporating into Hawking radiation over periods so long they resist comprehension. The universe is currently in its most life-friendly era. That is not an opinion. It is a measurement. The temperature is right. The heavy elements have been scattered by generations of supernovae. Planets have formed in abundance. Stars burn steadily enough to provide stable energy for billions of years. This is the window, and it is closing. Star formation is declining. Galaxies are running out of gas. The cosmic background temperature, which was once hot enough to melt rock, has cooled to near absolute zero and will keep cooling. Every direction you look, The conditions that allowed your existence are becoming less common. Cosmic expansion makes everything worse. Galaxies beyond our local group are accelerating away from us. The pool of accessible stars, the ones we could ever hope to reach or communicate with, is shrinking. Every second, more territory crosses the cosmic event horizon, the boundary beyond which light can never reach us. The universe is not just expanding, it is becoming unreachable. The neighborhood you can observe is getting smaller, not larger. We exist during the brief period when the universe allows complexity. Before this era, the cosmos was too hot, too uniform, too chaotic for anything like life to assemble. After this era, it will be too cold, too empty, too diffuse for anything like life to persist. Right now, in this narrow slice of cosmic history, the temperature is right, the chemistry works, the stars are burning. Before long, cosmically speaking, it will not. The window is not permanent. It is a phase, and we are living through the best part of it. The observable universe is shrinking. That sounds impossible. The universe is expanding. How can what we see be getting smaller? The answer is acceleration. Galaxies at the edge of the observable sphere are receding faster than light can travel. Their light still reaches us for now, because it left long ago when those galaxies were closer. But the light they emit today will never arrive. The space between us is expanding too fast. Every moment, more galaxies cross that boundary. They still exist. They still shine. They are still out there. But from our perspective, they are gone. The number of galaxies we can ever hope to observe is decreasing every second. The window for contact between civilizations is bounded by time and space, and both are working against us. Civilizations must emerge within a few billion light years of each other, and within a few billion years of each other. Otherwise, the expanding universe separates them permanently. The math is brutal. Two civilizations that arise 10 billion light years apart and 5 billion years apart will never know each other existed. By the time one's signals reach the other's location, the civilization that sent them will have been extinct for billions of years, and the recipient will have evolved past the point of listening, or will not have evolved yet. The isolation is absolute. The universe does not connect civilizations. It separates them. The expansion of space is not a neutral backdrop. It is an active force driving everything apart. Even if the galaxy were teeming with intelligent life, even if thousands of civilizations had risen and fallen across cosmic history, the expansion of the universe would ensure that most of them never knew the others existed. They would be born, live, think, build, broadcast, and die, all within a bubble of space and time that no other bubble ever intersected. We are not just trying to find a signal. We are trying to find a signal that exists within the same narrow slice of cosmic history as we do. A signal that was sent recently enough that its source still exists. A signal that was sent close enough that expansion has not stretched it beyond recognition. A signal that was sent at a frequency we happen to be listening to, at a time we happen to be listening, from a direction we happen to be pointing our instruments. The number of conditions that must align for detection is staggering. The number of conditions that must align for two civilizations to exist simultaneously within reachable distance during overlapping broadcast windows is even more staggering. The silence may not be a mystery at all. It may be the inevitable result of living in a universe that is expanding faster than any two civilizations can bridge. The silence may be the sound of the universe doing what it does, separating everything from everything else. We exist at a specific moment in our own development, a moment that appears from the outside to be the most dangerous phase any civilization passes through. Not because the universe is hostile, not because the stars are against us, because we have reached a point where our capabilities have outgrown our wisdom. The gap between what we can do and what we understand about the consequences of doing it has never been wider. Think about what that looks like from the outside. An observer watching Earth from a distance of a few hundred light years would see a planet that developed radio technology roughly 130 years ago. In the cosmic blink that followed, that same species built weapons capable of erasing itself in an afternoon. It engineered the genetic code of living organisms. It created machines that can think, plan, and act in ways their creators do not fully understand. It altered the chemistry of its own atmosphere to a degree that will take geological ages to reverse. All of this happened in less than a single human lifetime. The acceleration is not slowing, it is speeding up. We have enough technology to destroy ourselves. That is not speculation. It is demonstrated capability. The nuclear arsenals of the major powers contain warheads sufficient to end civilization as we know it. The delivery systems are maintained, staffed, and ready. The decision to use them rests with human beings operating under conditions of imperfect information, cognitive bias, and the pressure of events moving faster than any command structure can process. The Cuban Missile Crisis brought humanity within hours of that decision. Senior military officers acknowledged afterward that the outcome was partly a matter of chance. The next crisis may not be resolved by luck. We do not yet have enough wisdom, nor enough distributed presence in the cosmos, to survive the worst versions of our own capabilities. A single planet is a fragile container for a civilization. Put all your eggs in one basket, and that basket sits on a world where the temperature is rising, the ecosystems are fraying, and the political systems are struggling to keep pace with the problems they created. There is no backup. There is no colony on another world that could sustain the species if Earth became uninhabitable. There is no off-world repository of human knowledge that would survive the collapse of the civilization that built it. We are all here on one planet, with one atmosphere, one biosphere, one chance. This is exactly the window where a forward filter would operate. Not in the distant future when we have spread across the galaxy. Not in the ancient past when our ancestors were still figuring out how to make fire. Right now. At the moment when a species has enough power to end itself and not yet enough reach to survive its own mistakes. The filter, if it lies ahead, does not need to be a single dramatic event. It does not need to be a nuclear war or a runaway pathogen or an artificial intelligence that decides humans are expendable. It could be any of those things. It could be a combination. It could be something we have not yet imagined. What matters is that it works. And it works almost every time. Every civilization that has ever sent signals like the ones we have been sending for 90 years is either listening right now for an answer or it is gone. There is no third option that fits the data. If they exist and are broadcasting, we would have heard something by now. The silence is not ambiguous. It is not a puzzle waiting for a clever solution. It is a record of outcomes. Civilizations reach a certain point. They develop certain technologies. They face certain choices. And then the signal stops. We do not know which category they fall into. We do not know which category we will fall into. The data does not tell us whether the civilizations that went silent were destroyed by their own hands or by something external, or whether they simply chose to stop broadcasting and are still out there, thriving but invisible. The silence tells us that they went quiet. It does not tell us why, and that is the part that makes the question unbearable. We are running the same experiment they ran.
We are building the same technologies.
We are making the same choices. We are sending the same signals into the same dark. The only difference is that we are still here, for now. What we know is that the question Fermi asked over lunch in 1950 was a diagnostic. He did not know it at the time. He was just a physicist doing math in his head, wondering why the galaxy was not crawling with visitors. But the question he asked turned out to be a test that the universe has been running on every civilization that has ever reached our level of development. The question is simple: can you survive yourself? And every test we have run since has returned the same result. The universe does not answer. The silence is the answer. The question is what we do with it. If we are alone, the weight of it is almost impossible to hold. There is no backup. There is no second attempt at consciousness stored somewhere in the cosmos, waiting to continue the project of understanding if we fail. There is no archive of wisdom from older civilizations that we can consult when we face problems we do not know how to solve. There is no one to learn from. There is no one to warn us. There is only us, on one planet, in one solar system, in one galaxy among hundreds of billions, and we are the only minds that have ever emerged in all of it. If that is true, then everything that has ever been thought, loved, created, destroyed, or understood happened here. The universe has been producing stars and planets and chemistry for 8 billion years. And in all that time, this is the only place where something looked back and tried to understand. The only place where matter became aware of itself. The only place where the universe, through the medium of a conscious mind, asked the question of its own existence. If we fail, the universe returns to the dark. Not because it is punished, not because it is diminished, because there is nothing left that can see it. The darkness reasserts itself with the quiet indifference of physics, as though the 13.8 billion years that preceded us and the trillions of years that follow simply did not require us to exist. And they did not. We were never required. We were never guaranteed. We were an accident. A beautiful, improbable, fragile accident. And accidents can end. If we are surrounded, the answer is different but no less heavy. Every proposal for why the silence holds requires that civilizations like ours do not persist. The Great Filter, the Dark Forest, the Berserker probes, the astivating sleepers, the zookeepers, the simulation architects. Every single one of them describes a universe where civilizations like ours either destroy themselves, are destroyed by others, or transform into something that no longer broadcasts. Not one of them describes a universe where civilizations like ours thrive, expand, and fill the galaxy with their voices. Not one. The silence is not a mystery. It is a message. It is the accumulated data of every experiment the universe has run on the question of whether intelligence survives its own emergence. And the data says that the answer is no. Not always.
Not never.
But rarely enough that the sky is empty. Rarely enough that after 13 billion years and hundreds of billions of stars, we have found no one. The silence is the message. And the message is that the path we are on has been walked before by others. And it did not end well. What we do with that information is the only question that matters. We can ignore it. We can continue broadcasting, continue building the technologies that may destroy us, continue assuming that we are different, that we will succeed where others failed, that the silence does not apply to us. That is one option. It is the easiest option. It requires no change in behavior, no difficult choices, no acknowledgement that we might be walking toward the same wall that every other civilization hit. Or we can read the silence for what it is, a warning, a piece of evidence that the universe has been trying to show us for 13 billion years, and we have been too afraid to look at it directly. The silence says that civilizations like ours are fragile. The silence says that the window between the discovery of radio and the end of the broadcast is short. The silence says that something happens at our stage of development, and whatever it is, it happens reliably enough that the galaxy is empty. We do not know what that something is. We do not know whether it is a choice we make or a trap we fall into or a wall we cannot climb, but we know it is there. The silence is the evidence. The question is whether we will read the evidence before we become part of the dataset. The question is whether we will be the civilization that finally does something different. The question is whether we will be the one that breaks the pattern.